Hello all and welcome to this video for exercise 16D. We're continuing our look at the normal distribution and we're continuing, importantly, our use of the CAS calculator. This is very similar to exercise 16C, but instead of just being a really discrete problem where it's just a bunch of numbers, it's more of an applied problem or worded problems or real world problems. So let's just get straight into it. A bunch of the skills, the CAS skills, we already know from last class. If you need to brush up on them, we're going to quickly cover them here, but they are all in the 16C slides. So the marks on a certain test are normally distributed with a mean of 42. So straight away we get mean of 42 and a standard deviation of 6. So I would like to write out those key information straight away. If the pass mark is 40, what percentage of students pass the test? Well, we're asked for the percentage or the probability that a student, so we're effectively, and it's almost always assumed, but we're letting X be the student score. Yeah. And we want to know what's the probability that X, in this case, is greater than or equal to 40. And it doesn't matter, like we've talked about for normal distributions, if it's greater than or greater than and equal to, because technically in a normal distribution it's impossible to have the probability just for the exact value by itself. So we're trying to figure out that. And we can just use the normal 40 compared to 42 is not a whole amount of the standard deviation. So straight away we know we need to use calculator. So we're going to do a continuous, a normal continuous distribution. In our case, our lower bound is 40 because we need a 40 to mark. Our upper bound, as technically any normal distribution, normal distribution has technically goes from negative infinity to positive infinity. Standard deviation we had as 6, and mean was 42. So we just put that in there and we get 0.63 or 63%. Yeah, we could have put some decimal places in there, 63.05. Let's just do that for sake of accuracy. And it actually rounds up to 6 if I pay careful attention. So we get that. The top 5% of students will be awarded an A on a test. What mark would you need to achieve an A? So in this case, this is interesting. Let's be really clear. We're told the top 5% will be awarded an A. So we actually know the probability is going to be equal to 5%, or technically 0.05 as a decimal. And we want to know what score do you need to get. I guess we could call it A. We need to figure out what this A is. What score do we need to get so that we are in the top 5%? So since we know the probability and we're trying to find the actual value, this is an inverse problem. So we want to calculate an inverse normal distribution. Because we need to be greater than, we are doing a right hand side. So if we think of, come on calculator, why is that not? Why is it not letting me choose right hand side? They look great. Is it just me or is it? Let's go clear. Is it? It's not letting me. That was a bit weird. Okay, let's try that again. Distribution inverse normal. Right, there we go. That was a bit odd. Okay, but if we think of this situation, we have this and we want the upper 5%, and we're trying to figure out what that number there, A, is that we need to be, while we know that the mean is 42. So the probability we need is 0.05. We know our standard deviation is 6 and our mean is 40. This is weird that this is playing up. 42. Hit OK. There we go. So we get a 51.89. So in this case, A is equal to 51.869. So 87. Cool. So you need a score. What mark would you need to achieve an A? You would need a score of greater than 51.87 or 51.87. Okay. The next 15, and this is really clear, we're looking at problem C now. The next 15% of students will be awarded a B on the test. What mark would you need to achieve a B? So the next 15, so technically let's draw our little picture again, is the first 5%. Okay, they're getting an A. Now the next 15%, so between this zone here is 15%. Now we know on at least our Casio we've got that center version, but that center version only works if we're centered around clearly the center or the mean of the normal distribution. So we're having to do a right tail. Now how do we do a right tail for the next 15? Well, we just need to think, well, technically, this is going to be the top 20%. So we need this mark, that even though it's the next 15, this mark, let's call it B, would be the probability of X is greater than B should be actually 0.2. We need to be in the top 20%. And then we can worry about this top 5% later. We can take them out. So B is going to be equal, using our inverse distribution. Again, we want a right-hand side. We need the probability to be 0.2. Standard deviation 6. Mean of 42. Okay, so we get B value of 47.05. So our mark needs to be greater than 47.05. Now, to be really clear, what mark would you need to achieve a B? Well, yeah, it needs to be greater than 47.05. Okay, but we can't actually be greater than 51.87. So to get a mark of B, you need to be between 47.05 and also 51.87. Yeah, that's what your mark needs to be between to get a B. We take off the top 5%, and we're left then with the next 15%. So that's that. Now, just to be clear, because we didn't really look at it next class, got this slide in, is using the statistics tab to do the same thing. It actually allows us to see the normal distribution instead of us doing our little sketches. So if we think back to this very first problem, if I did a little sketch, do the normal distribution, we know the mean is at 42, okay, and I want to find pass mark as 40, what percentage of the students? Well, if the mean's 42, 40 is going to be just below it. Technically, I'd be finding the percentage in there. Now, the statistics tab can do all of that for us, all using the magic of computers. So we go back to menu and go into the statistics module. Then I've got all the instructions here, what to do. But you go into calculate, and we want to calculate a distribution. And we need to choose what type. So we ignore this table stuff up here when we're looking at the bottom. We want a normal CD. Okay. Continuous distribution, and hit next, and then we're just inputting the information same as below. So from part A from before, we had a lower bound of 40, a upper bound of infinity, a standard deviation of 6, and a mean of 42. Hit next, and it gives you your probability. It gives you all these answers. So your probability is 0.63 or 63%, which we got before. And it also gives you your Z-scores. So the lowest Z-score bound is you're technically a 0.33 standard deviations. And then the Z upper bound, it gives you 1.67e to 998, which is saying 1.67 by 10 to the power of 998, which that's the calculator's way of saying infinity. And then the very last thing you can do is also just click on the graph icon top left, and it plots it for you just like I have in the slides. And we more might care about the Z lower bound than the upper bound. Like I said, that's the calculator's way. But that's a pretty handy thing to not only tell you the probability, but also tell you your Z bounds in standard deviation. So that's that. The other type of problem though we need to deal with is what happens if we're actually told the upper and lower bounds with their percentage or probabilities, but we're then asked to work backwards and find the mean and standard deviation. So this is like doing an inverse, but it's a little bit more complex. And I've got one way of doing it here, which is work through this one, and then we're going to do another problem where I might show a slightly different layout of working out. So let's get into this one though. The volume of liquid in a bottle is normally distributed. It is known that 15% of the bottles contain more than 505 mils. So the probability of X being greater, where X is effectively the volume or how much the bottle is filled. The probability of that volume being greater than 505 is 0.15, and the probability, and then we're told in the next bit, and 3% of the bottles contain less than 501 mils. So the probability of X being less than 501 needs to be 0.03. Now, with these problems, because we're asked to find the mean and the standard deviation, the way you do all of these problems is instead convert the normal distribution to the standard normal distribution with a mean of 0 and a standard deviation of 1 to find z-scores of these two locations, and then go backwards, or find what the z-scores to get these probabilities. We care about these probabilities. If we first find what the z-scores are, that give us those probabilities in a distribution with the mean at 0 and the standard deviation of 1 and positive 1, if we find the z-scores of that give us, in our case, we want the lower 0.4, let's just say 3%. We want the lower 3%, and then we want the upper 15%. If we find what the z-score of that point is and the z-score of that point is, we can then bring that to our problem through using the z-score z-value algorithm. But here's a graph picture of it, of the distribution. We know 505, that top end's 15%. We know 501, the bottom end is 3%. Clearly that must mean the mean is somewhere between it, and we don't know what it is, and we don't know the size of the standard deviations. So how are we going to do it? Well, one is convert these, instead of dealing with X, like I said, we're going to deal with instead Z values. So as a quick reminder, the Z value, or is the whatever X is, take away the mean, divided by the standard deviation. So in our case, if we want to convert X to Z, well, we have to put this 505 into that there. And we're going to do the same for 501, put that into there, and get 0.03. Cool. Probably a little bit confusing at the moment, and I'm hoping when I show you the next method to go about this, it might make a little bit more sense. But what we've done by doing this now is instead of this bottom distribution, we're not dealing with this anymore. We're now dealing with this one, which is our standard normal distribution with a mean of 0 and a standard deviation of 1. And we want to find what are the Z values, or how many standard deviations do we need to be to get the bottom 3% and the top 15%. So we can get those, and let me go back to our main here. It turns out those Z values, we could, instead of this bit here, just think of it, that's saying Z is equal to that, and Z is equal to that. Yeah, we can get that. So how do you get these numbers? How do we get these new decimals? Well, it's just doing an inverse normal distribution. In our case, we want to know what z value, and we wanted before that was z greater than, z is greater than what value is going to give us the bottom 0.03. We're trying to figure that out. That's where this 1.03 has come from. So we do interactive distribution inverse normal. Okay, and so we want, I've done that there, because it needs to be less than a certain number. We want the left, we want the probability to be 0.03. We want a standard deviation of 1 and a mean of 0. That's the normal distribution. That gives us, oh, sorry, I've changed the order of the way these things are written. That gives us a negative 1.88. So, negative 1.88. That's what, that's how many standard deviations we need to be away from the mean. It doesn't matter what the mean is, and it doesn't matter what the size of the standard deviation is. We just know now, having done that inverse on the calculator, we know we need to be negative 1.88 standard deviations away. So we now know that this point here is negative 1.88 standard deviations away. And we're just going to repeat the process to figure out for the top 15%, how many standard deviations do we need to be away to be in the top 15%? We don't care how big the standard deviation is. We don't care what the mean is. We just want to know what our z value needs to be to give us a probability of 0.15. So again, we're just going to do an inverse normal distribution. This time we're going to do a right-hand side. We want our probability to be 0.15, standard deviation of 1, mean of 0, and it gives us 1.03. We need to be 1.036 standard deviations away to be in the top 15%. So what does that leave us now? Well, that gives us that effectively tells us what our z's are. Okay, we have, let me write this. Okay, take this away. Okay, we have a z score is going to be equal to negative 1.88079, and we have a z score that we need of 1.0643, and we know that for the standard one, this one up here. Okay, how can we convert those z values that we've just got, or how can we relate them to our problem, our normal distribution here? Okay, and we can use, and this is incredibly messy, we can use this rule here. Z is equal to x take away the mean divided by the standard deviation. So in our case, this negative 1.88, that is going to be the x value we're told that gives us that bottom 3% is 501. So we have 501 take away whatever our mean is going to be divided by our standard deviation. Same for this top one. We're told in our normal distribution that we care about, that gives us the top 15%, our x value is 505. So we're going to have 505 take away whatever our mean is divided by the standard deviation. So that's a lot of work just to get to this, and it's a lot of explanation. But what do we have now? Well, we have two equations that has two unknowns. If we have two equations with two unknowns, we should be able to solve these using simultaneous equations. And since we've got our CAS, there's no point doing this by hand. Let's just chuck it. Okay, so we're going to now solve these using the simultaneous equations on our CAS command. So just go into keyboard. Where is it in math? There you know. That's Where's it gone? There we go. Next to the 2 DMS button, there's our simultaneous equation solver. So our first equation, we have negative 1.88079 equals, let's put in a fraction thing that will just make it a little bit clearer, 501 take away. I'm going to call the mean x, and it's divided by, and I'm going to call the standard deviation y. And then my second equation is 1.03643 is equal to 505. Let's put a fraction in. 505 take away x divided by y, and we want to solve for x and y. So we got x, which in our case was our mean. We get a mean, and I've got a spot to write it down. Our mean was equal to 503.57, and our standard deviation was 1.3712. So there we go. Right, so let's do that again now, but a bit quicker with a lot less of the talking to try and build the process. The diameters of the rods produced by a certain machine are normally distributed. It is known that less than 1% of the rods measure more than 30.2, so we know the probability that x is less than 30.2 is equal to 0.01 to give us 1%, and 0.5% of the rods measure less than 29.8. So we also know the probability that x, being the length of the rod, being less than 29.8 is equal to 0.5%, which is 0.005 as a decimal. So there's one just gotcha. Making sure we get decimal. Now the way I'd go straight at this is I don't care so much about the x values at the moment. I want to know what the z values are they give us. So what z value gives us a probability of 0.01, and what z value gives me a probability of 0.005 in a normal distribution. So I'm pretty much asking probability of z less than, let's just call it a, needs to be equal to 0.01, and I want to find the probability z, it needs to be less than, and this one we'll call it b, is equal to 0.05. I want to figure out what a and b are in a basic standard normal distribution. So straight away I'm going to go into distribution inverse normal, and because I need to be less than, oh no, I've misread this. No, 1% of the rods measure more than 30.2, so this needs to be a greater than. There we go, and 0 points less than 29.8. Okay, yeah, that's fine. Okay, so I just had to make that correction there. So in our case, actually, we want a right-hand side for this one. We need the probability to be 0.01 as a decimal. Mean standard deviation will leave because we're dealing with the basic version. And so that tells us we need a needs to be equal to 2.32635. Okay, so we need to be 2.3. Doesn't matter what our mean, what our normal distribution is, our mean, our standard deviations. We just need to be 2.32635 standard deviations away from whatever the mean is for that one. And now for this one, b is going to be equal to, same thing, inverse distribution. Now we're doing a less than, so we're going to do a left-hand tail. Probability is 0.005. Mean standard deviation leave the same. We get negative 2.5753. So in that case, we don't know what our size of our standard deviation is yet, but we know we have to be less than, or technically it's greater than, 2.57583 standard deviations below whatever the mean is. So from this, we know what our z scores are. So our z is equal to 2.3263, and that's going to be equal, into our case, R value that was giving it, our X value that was giving it was 30.2. Take away whatever the mean is going to be, divide by the standard deviation. Okay. And same for over here, our Z score is equal to negative 2.57583. And that would be equal to the diameter, that our X value that was giving us, that was 29.8. Take away whatever the mean is and whatever the standard deviation. We have two simultaneous equations, so we're going to solve them using our CAS. So same thing, 2.32635 is equal to 30.2, take away, same thing, I'm just going to use X and Y in place of negative 2.57583 is equal to 29.8, take away X, divide by Y, and we want to solve for X and Y, and we get our mean, or X as our we used the variable in our calculator, is 30.0102, and our standard deviation is 0.081596, so that technically we would round that up to 60. Yep. There we go. So I hope that makes a little bit more sense. Is yes, we start with the problem in terms of X, but instead of dealing with that first, convert straight to dealing with in terms of Z. How many standard deviations? That's what these numbers are. These are telling us how many standard deviations we need to be away in any normal distribution to get that required probability, Doesn't matter what the size of the standard deviation is, doesn't matter what the mean is. Those are how far we need to be away in standard deviations. Then you can use those to generate these two equations to then solve using simultaneous to get that. That's it. I hope that makes sense. As always, see you in class. If you have any questions, stick them below or shoot me an email. Thanks and have a good evening.